indexed, and so forth. In the case of data intensive computing, data intensive application development, their data will be enormous size in the range of megabyte, terabytes to petabytes. You can recall an example I gave you, how Facebook is handling its data, how WhatsApp is handling its data, how Twitter is handling its data, how Instagram is handling its data, how scientific computing applications handle data. Earlier, output-driven programming. Now we need to think about data-driven programming. Data is very, very important. Because wherever you see, data is very, very important. Based on the data, you do a lot of analysis. Every day you are getting messages from Amazon, Flipkart, and so forth. So many business sites. How do they get information? How do they send you information? Saying that you are interested in so and so, you have searched for these items. How do they really do it? Do you think the number of customers in Flipkart, Amazon, and so forth? Do you think how much data they are processing? Maybe per hour, per minute, per second, per day? How are their data structures handled? How are their databases handled? For instance, a mobile phone company is keeping all mobile subscribers' information. How do they really handle it? Lot of intelligent behavior is also there seeing. When you go out, if you open Google Map says it records all your movements, and then finally it tells you that last year you went to this place, do you want to go again? So 1 year data they will process. This is just I am trying to give you examples of data intensive analysis and computing. So when you are thinking about such enormous data, and you need to do a lot of mining using the data and do some analysis, do some business, you need to have proper infrastructure for that, proper facility for doing all this, proper computational capability must be there to handle large amount of data, large volume of data. There are multiple examples I can mention. Hundreds of gigabytes of data are produced every second by telescopes when it is mapping a sky. Collection of images of the sky easily reaches some petabytes. Suppose biometric information is being accessed and mining of databases are done, then it may require some terabytes of data. Earthquake simulators require massive amount of data. Recording earth vibrations require lot of data analysis. There are so many scientific computing in several IT industry sector. They require facility for data intensive computation. Customer data of any telecom company may require process of 10 to 100 terabytes of data. People say that so many petabytes of thousands of petabytes of data per month would be handled at present in 2020. So think about the situation where 3 years or 4 years back, when you had a mobile phone, you are working with very limited amount of data transmission. Is that right? Now, because of our class also, a lot of amount of data is being transmitted between you and me. That is also data intensive computing only. The Google Meet, which is using lot of data transfer from my end to your end, and to show this presentation is also data intensive computing. Hundreds of users are being connected at the same time, and everyone will be seeing the same screen, and voice recording, video recording, movement recording, PPT recording, everything will be done through this. This is what the data intensive computing means. So you must have infrastructure for handling this, like high-speed internet maybe. You must have a data storage location to store this data. So my class is being recorded and it will be kept in the Google Drive. It will be stored in the Google Drive. After 1 minute or 2 minutes, your video will be available in my Google Drive, and you can also see the class which I am handling now at your place, at your wish, at your time. So all these are very, very important aspects of learning data intensive computing. 3 years back, we were not at all using internet with the data, like mobile phone with a large amount of data. Now, even 1.5 GB of data, it's very less for us. Are you getting my point? Similarly, you go to Big Bazaar, lot of people will come there, lot of transactions will go on, and lot of business will go on, lot of items are being taken, purchased. And how do they do inventory? Every day you need to see how much items have been bought by various customers, and which are all the items we need to procure fast, because seasonal items also need to be handled. So all these are considered to be mining of data. So all these things need to be handled carefully, so that your process of execution, your leveraging your computation, leveraging your business, all that will be very, very important. So these are the things which you need to know, that in this chapter, we will discuss all this. What are the different research avenues available here? What are the challenges available here? How we can go with large amount of data handling. So we'll continue our discussion on this. Data intensive computing focuses on class of applications that deal with a large amount of data. Computational science to social networking, yes, remember social networking, produce large volume of data that needs to be efficiently stored, made accessible, indexed, and analyzed. So it should be stored efficiently, it should be made accessible. I was astonished. You are also surprised to see the same photo in your Facebook will be seen by multiple people at the same time. What type of data structure is it? How do they really handle it? Is it a database, or it is a network of database, or a relational database? Think over. Because at the same time, all your friends will be able to see your data, your photograph. Maybe yesterday you have celebrated Deepavali, maybe you have put some photographs, and those photographs can be seen by your friends and family. How do they really? At the same time, they will access the data. How do they really do it? How the data is indexed? How the data is analyzed? Now using Google Eye, if you show the photograph, they will tell you the location of that photograph. They will analyze the photo. They will analyze the data. So much complexity is involved in this. You should know how to develop applications to do this. Interestingly, you please understand, programs will go, algorithms will move to the data where data is located. Earlier, we used to access data from a location and use the data for our computation. But now, algorithms are moved to the location where the data is available. Very, very interesting point to note this. So you will forward the algorithm, you move the algorithm, you move the program itself to the location where data is available. That's very interesting to understand. Distributed computing is definitely of help in addressing these challenges. So distributed computing, because large amount of data, so even a large amount of work is there, how do you do it? You distribute the work into various locations, various persons, various people. You give the data, okay, you do this data, you do this data. You segregate. 100 colleges are there, so you give 25 colleges to one person who will handle that. It's very easy to handle. No? Similarly here also. So the large amount of data is there. You give chunk of data to various computing elements. They will analyze the data, they will process the data, they will compute the data, and then they will give the data back to the originator. So this is where distributed computing is of much use. In this chapter, we understand the nature of data-intensive computing and presents an overview of challenges of large volume of data and how they are handled. I think now you have got the idea that what is the importance of data now. So it is a data-driven programming. Whenever you are thinking about developing an application now, think about the application for data or data for application. Okay, so application for data now, this is the scenario. So whenever you are learning new things, learn for data intensive computing. So I have given you some examples here. So large scale data may be in the megabits to petabytes or beyond. Data set is the word which is used for the collection of data. So the large amount of data is considered to be a data set. When you say data set, it is a set of data, or data set is the collection of data. Large amount of data is being considered as a data set. Data set means actually it's a repository of data. All data will be stored in a location, it's considered as a repository. So to access the data, you need to have some information, how to access that information, how to access the data, how to access the data set, where is the data set available. So you will be having some metadata for the data. So data for data is called a metadata. So metadata will be available for all the data sets. So they will be used to access the data. As you know already, data-intensive computations occur in many application domains. So you have so many domains like computational science, natural science, biometrics, as well as social networking. All these are considered to be areas where large amount of data is being used. Computational science, people conducting scientific simulations, experiments, and produce and analyze, process huge amount of data. Biometric information, biometric applications mine databases that may end up containing terabytes of data. So you think about our Aadhaar information. Our Aadhaar information is a biometric information. Suppose you have a biometric access of data, then you will be taking your thumb impression, your iris information that need to be analyzed. It is 130 crore, 135 crore people data need to be accessed, processed in a very short period. Then only you will be allowed to enter your place, or they will be given access to do some official work. So it is very, very important to do that. So biometric information requires large amount of data, terabytes of data. Earthquake simulators, which I told you just now, process a massive amount of data which is produced as a result of recording the vibrations of Earth across the entire globe. Okay, next is characterizing data intensive computation. What are the characteristics of data intensive computing? It deals with large amount of data, huge amount of data, huge volume of data, also exhibit compute intensive properties. As you say, once the data is there, data intensive is there, automatically it is computationally also intensive. Always you remember this. Handle data sets on the scale of multiple terabytes and petabytes. Applications process data in multi-step analytical pipelines, including transformation and fusion stages. So the whole data will be divided into multi-step analytical pipelines. So you'll have pipelines for data analysis, data processing, data storage, indexing, everything. It will be done in a pipeline process. So the transformation will be done to segregate the data into multiple locations so that distributed computing is applied there. And then finally it will be fused. So get the data from those distributed computing environment to your location, access the data back to. There are so many challenges available. So there are challenges for data intensive computing. There must be data analyzed, data to be produced, data to be stored. So when you look at the production of data, analysis of data, storage of data imposes requirements on supporting infrastructure. You may be wondering why I have given you the first assignment of writing a program in multi-threaded environment. I asked you to generate the data. I asked you to generate something like 1000 cross 1000 matrix. 1000 cross 1000 matrix. 1000 cross 1000 matrix need to be generated. 1000 cube data need to be generated. 1000 square data, 1000 into 1000 square data need to be generated. And you need to multiply two matrices. Think about it. How you have generated the data? You have written a program for that. You say there must be a program to generate the data even. You can't enter the data, 1000 rows and 1000 columns of data. You can't enter the data into two matrices and then third matrix generated. So you have generated the data for that. So you need to have a program for that. Similarly, here also, when you are thinking about large amount of data, you must have supporting infrastructure for that. And there must be a middleware to get traditional solutions for distributed computing. So whenever you are thinking about from one system, you need to distribute the data into multiple locations. You remember that there must be a middleware which will be helping to distribute the data into pieces, and then it will be transmitted, and then it is monitored for computation. After the computation, it takes back the data, it fuses the data, it compiles the data, it regenerates the data output, and then it is taken back to the originator. So for all these things, there must be a middleware. When the data is being sent to distributed environment, the location of data is very critical. Location of data. So how do we transmit so much of data? Maybe in the terms of terabytes. The data need to be transmitted in terabytes, and if it becomes an obstacle for high performance computation. So data partitioning as well as content replication and scalable algorithms help in improving performance of data intensive applications. So you can't transmit terabytes of data into a particular location. So instead of that, you divide that into pieces, make it scalable, and then you ask the distributed computing environment to compute, process the data, and get back. So this is how it is being done. There are challenges available, challenges listed. Let me check. Huge amount of data produced, analyzed, stored in process requirement, which moving of terabytes of data partitioning, content replication, scalable algorithms help in improving performance. So these are the challenges available. I'll come back to the picture, figure 8.1 little later. Just look at, these are the challenges which data intensive computing listed by Ian Galton and others. Scalable algorithms that can search and process massive data set. Algorithms are scalable. Algorithms are not static. Understand this. You develop an algorithm, it cannot be a static. It should be a generalized. So you can think of, suppose when you are processing data, it is something like 100 cross 100 data. The same algorithm, can it be used for 1000 cross 1000 or 10,000 cross 10,000? Is there any issue in data segmentation? Is there any issue in code segmentation? So think about such a situation where when you have developed an algorithm which will be handling gigabyte of data, suddenly it becomes a terabyte of data. Really, can you handle that data? Your algorithm will support that or not? How much time it will take to process the data? So all these are considered to be the challenges when you are developing a scalable algorithm. New metadata management technologies that can handle complex, heterogeneous, and distributed data sources. Metadata management technologies that can scale to handle complex, heterogeneous, distributed data sources. So the data is complex, data is not homogeneous data, different types of data available, and also distributed data sources. Data source is also distributed, very interestingly. So this is the real challenge. Advances in high-performance computing platforms for accessing in-memory multi-terabyte data structures. Just now I was mentioning a data structure, you define a data structure. Can you define a static array data structure for such a high volume of data, wherein it is in terms of terabytes? You need to think about dynamic data allocation, dynamic data structure definition. So think about your understanding about accessing, creating, allocating, reallocating data in the languages which you have studied, C, C++, Java, Python. How do they really handle so much of volume of data? Will they go for a static array, static data structure? No, dynamic data structure need to be created. So you need to think about all other segmentation, errors, and manipulations also while developing such applications and algorithms. High performance, highly reliable, petascale distributed file system. Again, so you can't rely on only data structure. You need to have a file system also where you can handle petabyte data available in a distributed file system. High performance also, highly reliable also. Remember, it should be highly reliable as well as high performance as well as distributed file system. This is the real challenge in data intensive computing. Data signature generation techniques for data reduction and rapid processing. Again, you need to have algorithms for data reduction. You need to analyze, you need to narrow down the data. When you narrow down the data for accessing or processing the data, while processing and submitting data to algorithms, if you do data reduction before actually computation, it is also very, very important to note. New approaches to software mobility for delivering algorithms able to move to the computation where the data is located. Very interestingly, software mobility to move computation where data is present. Very interesting. Data was coming to computation. Now we are thinking to move computation itself to the data because retrieving data, accessing data is costlier than moving the program itself to the data location where the data is available. Very interesting point to note this. Flexible, high performance software integration techniques facilitating the combination of software modules running on different platforms to quickly form analytical pipeline. Remember this point also. Interconnected architectures that provide support for filtering multi-gigabyte data streams. So there must be scalable algorithms. It can process massive data set. New metadata management for handling complex, heterogeneous, and distributed data sources. Advances in high-performance computing platforms accessing in-memory multi-terabyte data structure. In-memory data structure is created. It will be there in memory to access the data. High performance, highly reliable, petascale distributed file system. Data signature generation techniques for data reduction and rapid processing. So it is sort of indexing. Software mobility to move computation where the data is present. So data movement is costly. So move the computation only to the location where data is available. Interconnected architecture that provides support for filtering multi-gigabyte data streams. Software integration techniques that facilitate the combination of software modules running on different platforms. I'll go back to the picture given there. You can see data intensive research issues available here. So heterogeneous formats, distributed petabyte, same thing which we have listed in the next slide has been shown in a pictorial representation. Just try to understand the picture. Data complexity, it's in terms of volume, in terms of format, in terms of distribution. So types of volume, so you can divide some gigabytes of data, or in which format the data is available. The same format should be compatible with the distributed environment. For this, you need to use some transmission mechanism, understanding mechanism. I already told you XML is a location, the bridge between your computing element as well as the location of data, how the data is processed, how the data is transmitted, so that data from the origination till the end, it should be understood. Distribution, how the data is distributed. And when you are distributing the data, the same data should not be sent to two different locations. You should have a record of that, what data has been sent to which node. Data intensive problems are available. Only data intensive problem. So large amount of data is processed here. Data as well as computation also intensive, like weather forecasting. Data is also there, computation is also there. Flight simulation is another example. Maybe social networking also you can think of. It's only a data display. Where you are doing some analysis, you are trying to match the image or the video from the video repository with the data which has been fed. Current problems, computation intensive problems. So you have these type of problems where data complexity is there, heterogeneous formats are there, homogeneous formats are non-distributed megabytes or gigabytes of data available, model solvers, simulations, simple search is also there. So it is telling you the complexity, it is explaining the data complexity here, it is telling you the computation complexity. This is increasing the computation complexity. This is telling you the data complexity, the rising of data complexity here, rising of computation complexity. This is what the current problems which we are trying to solve. So these are all the new problems which, because of the data intensivity as well as computationally intensive problems. Statistical models, decision support, knowledge generation. Nowadays you can think of adding one more, which is machine learning as well as artificial intelligence also can be added here as a computational as well as data intensive applications. So now I'll stop my presentation. You can go for question answering. If you have any questions, you can put your questions in the chat box. I'll try to answer. I'll stop my presentation now.